Hello guys, my name is Kumari Satyamaganga. The three-digit name is 036. And in this video, I will explain about my answer in the linear algebra 7 assignment. First, number 8, part A. Give a point in third dimension vector space with scalar E, which is the element of R, and use matrix multiplication to determine which is the shadow of that point. And for the part A, which contraction with a factor of k, which is less than 1. So my answer, contraction with a factor k less than 1. So uh, I have a point here which is 4, 1, 4, and we know k is, and I decided k is half. So the answer is we built a k which is like similar with the matrix identity, and we multiply that with the point here for 1, 4, and that is equals to this, the result, and that gives us the uh, matrix vector is 2, half, and 2. So the contraction is, the point is 2, half, 2. For the part B, which is we must find the shadow, the relation with the factor k um, more than 1. So I have a point again, this is 2, 2, 2, and I decide that k is 2. So we just repeat the same process, which is the k is like empty matrix, and that is multiplied by the point. And we got the result here, and we produce this new point, which is the 4, 4, 4. So the deletion, which is the shadow of the point, is 4, 4, 4. For the part C, we must determine the shadow of a point with it is the expansion in the direction of x-axis with the factor k is more than 1. So I have a point here, 3, 3, 3, and k equals to 2. And is in this t, x, y, z, which is why we go to the direction is x-axis, we choose the x coordinates, x-axis, that is multiplied by k. So not every element in this identity matrix becomes a k. So just the x-axis. So a bit different, but it's it's uh it's maybe like the same, but here is the x-axis, which is that is changed to k, and that is multiplied by the point here, 3, 3, 3, and that produces this result, which is 6, 3, 3. So the expansion in the direction of x-axis is 6, 3, 3. So for the last part is part D, which is compression with the direction of y-axis, the factor k less than 1, and I have a point again, which is 4, 4, 4, and k I use 1 over 4 for a quarter, and the x, y, z here. Now we change or multiply the x-axis. So here the changes is in the y-axis, which is y column in the identity matrix, and that is multiplied by the point 4, 4, 4, and that produces the 414. So the compression in the direction of y-axis, which is the shadow, is 414. Next, we go to the uh, next problem, which is number 9. Give a matrix operator, which is a 2 by 2 size, and picture the uh, transformation of square within the first quadrant as operated in that matrix. So here's my answer. And first, we decide the basis. So I just use the ordinary basis here, and that is multiplied by the x and y axis. And I decide the both of the vectors here, which is 2, 1 for phi, and u is 1, 4. So here we can see uh, the picture of that matrix in the quadrant, in the first quadrant. And here we have the shadow or the reflection of that picture in the first quadrant, which is in the second quadrant. And here we got the result for the transformation matrix, which is the reflection. Here we multiply the basis with each of the vectors, so we get the shadow of that vectors, or we can call it the reflection of that vectors, which is the t v. The transformation of vector v is -2 and 1, and the transformation of vector u is -1 and 4. And here are the pictured in the second quadrant. Now we shall go to the next problem, which is problem number 10. And in this problem, we must choose two problems in the exercise 4.9 between number 23 and 32. So I choose number 31, part A. So the problem is find the standard matrix for the operator that rotates each vector 30-degree counterclockwise about the z-axis and is looking along the positive z-axis toward the origin. And here are my solutions. So the standard matrix for the counterclockwise rotation about the positive z-axis to an angle theta is this. So consider the operator, which is shown in the problem. So above the definition, the standard matrix that rotates its vector 30-degree counterclockwise about the z-axis is this, which is equal to this. So if you remember, cos 30 degree, which is equal to root 3 over 2, and minus sinus 30 degree, which is equal to minus 1 over 2, and the sinus 30 degree, which is half, and cos 30 degree, which is same as which is the root of 3 over 2. And therefore the standard matrix is this, the result. So the next problem is I choose the problem number 27. So find the standard matrix for the reflection of in the two-dimensional R vector space about the straight line, and then use the matrix to find the reflection of the given point about that line. So the reflection of 3, 4 about the line that makes an angle of 5 over 3 is equal to 60 degrees with positive x-axis. And here the same The standard equation for the reflection of the point above the line is h theta, which is equals to cos 2 times theta, sin 2 times theta, sin is 2 times theta, minus cos 2 times theta. So consider the point 3, 4 onto the line that makes an angle π/3 with positive x-axis. Thus, the standard matrix by above definition is